So, an introduction to derivatives. We're going to go back to Math 10 and pull some information that you learned out of that course. And that was how we calculated the slope of a line. Does anybody remember the formula for that? M is equal to... That's the equation of a line. So slope of the line is y2 minus y1 over x2 minus x1. That being your rise when you subtract your two y values divided by the run when you subtract your two x values. So if we had a line that had, say, this point on it and this point on it, then we could easily find the slope of that line. 1 minus minus 2, that's y minus y, over x minus x. 1 minus 1 minus 1, 1 minus minus 2 is 3. 3 minus 2 is negative. 3 minus 5 is negative 2. And we get a slope of minus 3 over 2. Yeah, I kind of remember doing that? Math 10, finding the slope of a line. So we need 2 points in order to calculate the slope of a line, because that's how we find slope. Rise over run. Y minus y over x minus x. So, what is a derivative? Well, here is a very simple definition of what a derivative is. The derivative is the slope of a line that is tangent to a curve. The slope of a line that is tangent to a curve. So you can imagine if we had a little curve here. Let's draw. And let's say we wanted to find the line the slope of the line that was tangent to that curve. So that would be a derivative right here. The derivative is the slope of a line that is tangent to a curve. So here's the line that is tangent. Remember, a tangent means it just nicks the curve at one point. So that's a tangent line to the curve. We would want to find the slope of that line. Do you see what the problem is? What do we need to find a slope? 2 points. When we have a tangent line, how many points are connecting our curve? 1. So this is our big problem. What's the problem? A line that is tangent to a curve has only 1 point on the curve. Right here. So how do we find the slope of a line when there's only 1 point that we have to work with? That's our problem. So in this little sketch here, this is the graph y equals x squared. It's your good old friendly parabola. And let's investigate what would be the slope of the tangent line at 1, at x equals 1. So we'd want to know what is the slope of this line right here. Let's make that our question. So we've mentioned that we've got a problem because we only have 1 point. But what if I made 2 points? What if I said, let's take this point here, and we know the coordinates of this. That's the point 1, 1. Right? Because this is the graph y equals x squared. What if I took the point 2, 4? That would be this one. We know that's another point on the parabola. And what if I connected those two? I don't know if I'll be able to get a line that goes through there very nicely. There we go. Could we find the slope of that line? We've got 2 points, right? So we could find that. What do we call lines that go through a curve in 2 points? Secant. It's a secant line, that's right. So the slope of that secant line, we would go y minus y, so 4 minus 1 over 2 minus 1. So we would have the slope of this line equal to 3. Is that the slope of our tangent line? No. No. Would it be relatively close? Yeah, kind of, right? A little bit more, is it a little bit steeper or not as steep? A little bit steeper. So we would know that the slope of the tangent line would be something slightly smaller than 3 because the black line is a steeper curve than the green line, which is what we want. How might we get a better approximation?
We could just keep testing it closer and closer.
Like find another point that's not so far away, is what you're saying? Yeah, why don't we try, let's try 1.5. So that would be right here. So an x value of 1.5, what would our y value be at that point? Well, y is equal to x squared, so 1.5 squared, that would be 2.25. Right? If you take 1.5 and you square it, this point on our parabola would be 2.25. Let's do that one in blue. Try to draw this here as best as I can. And if we figure out the blue slope, again it's a secant line, y value was 2.25 minus the y value of 1 over x value was 1.5 minus its y value of 1. So we would get 1.25 divided by 0.5, which is 2.5. So the slope of this line is 2.5. Would that be a better approximation? A little bit closer to what the true slope of the tangent is? Yes? Is it the slope of the tangent? No. So what would be a better choice for our second point? A point very close to 1. Why don't we try, let's see, do I have any more colors? We can do reddish, sort of. Let's try a point right here that has an x value of 1.1. Now, what would its y value be? You'd put 1.1 in here for x and square it. 1.1 squared is 1.21. And the slope of that secant line would be 1.21 minus the y value of the first point and the x value of this point minus the x value of that point. So we would get a slope of 0.21 over 0.1. And 0.21 divided by 0.1 would be a slope of 2.1. Closer yet, right? We would see that that red line would be now very close to the slope of our tangent line. But not exactly. So we could go 1.01 as our second point. And we could get a y value, and we could do a slope, and we would get closer yet. Okay, let's consider this graph here. This is some function y equals f of x. And we saw back in our curve up here that we wanted those 2 points to be as close as we could possibly make them. If we can make our 2 points as close as we can, then we are going to get a very good approximation of what our true slope of the tangent is. So let's consider a more general function, this one right here. And let's say I want to find the slope of the tangent line right here at this point, x. So this point here is x. And it will have a y value of f of x. Okay, so the coordinate of this point right here is x comma f of x. Now what I'm going to do is I'm going to take, just like we did before, another point out here that is x plus h. So just a little bit bigger than what x was. because we must have 2 points to calculate slope. So back here, when we were looking at this one, the x value was 1. Here, the x value was 2. So I was 1 more than my x-coordinate here. Then we tried only going a half bigger. And finally here, we were only 0.1 larger. So we will do some x plus h value, which would correspond to a y value of f of x plus h. And if I found the slope of the line that connected those 2 points, my formula would be, just like we did before, slope is always y minus y over x minus x. So with our points here, it would be y. Oh, let's put the coordinates of the points on here. So this was x plus h. That's our x-coordinate for this point. And f of x plus h is our y-coordinate for our second point. So slope y minus y over x minus x. The y value is f of x plus h minus this y value, which is f of x, all over this x value, x plus h, minus this x value, which is x. So there's our slope of our secant line, the line connecting any 2 points on our curve. And notice the denominator here, x plus h minus x, means that the denominator will simplify to just h. So this was the slope of our secant line. This was the slope of the line that connected those 2 points on the curve. Ideally, what do we want to have happen to h? This h right here. We would like that h value to become 0. We want to make it as small as we can. So we'd like to actually move the h value so that it's basically right on top of the other point there. So the 2 points are bang, bang. And if we make h really small, then what does that mean we are doing when we're making h approach 0? We call that a limit. So why did we spend all that time working on limits? Because everything we do in calculus when we're finding derivative is we are doing a limit. So this is the important part right here. The slope of the secant line is this formula right here. The slope of the tangent line, which is what we call the derivative, is the limit as h approaches 0 of our slope formula. The slope of the tangent line is the limit as h approaches 0 of our slope formula, which is y2 minus y1. So f of x plus h minus f of x over h. The limit as h approaches 0. Now, what is going to be the problem with that limit? What can you tell right now when you look at that limit that's going to be a big problem with it?
H is 0.
And where's h? In the denominator. So we would always love when we're working on limits to just take the number and substitute it in for h, but every single time our denominator is going to be 0. And of course we know we can't divide by 0. So the derivative formula is not an easy one to work with because you'll never be able to just substitute in and it'll work. Because every time you substitute 0 in for h, you will get 0 in the denominator. So we'll have to look at some questions where we could evaluate those things. So let's go back and look at this parabola again. And the original problem was, what is the slope of the tangent line at x equals 1? What's that slope right there? Well, we know right now that the slope of the tangent line is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And in our example, what is our x value that we're interested in? 1. So this is the graph of y equals x squared. We want to know what is the slope of the tangent line when x is 1. So slope of the tangent line will equal the limit as h approaches 0 of f of 1 plus h minus f of 1 all over h. So we are going to put in, this was our xy value, and then out here we had 1 plus h and f of 1 plus h. That was our second point. But we're going to make that h 0. We're going to make that h 0. So, limit as h approaches 0. F of 1 plus h, how are we going to figure out what f of 1 plus h is? Yeah, there's our function right there, right? Y equals x squared. So f of 1 plus h, that's function notation. Maybe we should, instead of calling it y equals, let's use actually f of x. F of x equals x squared. So what is f of 1 plus h? Well, we're going to stick 1 plus h in for x. So 1 plus h squared minus f of 1. We would put in 1 in for x. 1 squared is 1 over h. So f of 1 plus h meant we replace the x with 1 plus h. So we would get 1 plus h squared, and f of 1 is 1 squared, which we said was 1. So now we just need to figure out what is 1 plus h squared. Lots of Math 12 students still do this. 1 plus h squared doesn't mean you just square each individual thing. 1 plus h squared means 1 plus h times 1 plus h. So you got to FOIL it out, right? Yeah, so you would get 1, let's write the limit as h approaches 0, of 1 plus 2h plus h squared minus 1 all over h. And this tidies up very nicely, because the 1s would cancel out. And then in this particular question, you can see that this h in the denominator will cancel nicely with the h's in our numerator. So it's limit as h approaches 0 of 2 plus h when you divide both of these terms by h. And now we can substitute in 0 for h. And we get 2. So what is the slope of the tangent line as x approaches 1? At x equals 1? The slope of our tangent line is 2. And when we go back to our little example we are doing here, we started with a slope of 3, and as we made the h value a little bit smaller, we got down to 2.5, then we got to 2.1, and now using limits, we have shown that the slope is exactly 2. So just to summarize what we've done here, what's the definition of the derivative? The definition of the derivative is the slope of a tangent line, or the slope of a line tangent to a curve, is given by the following formula. M tan, or slope of the tangent line, is a limit as h approaches 0 of f of x plus h minus f of x, that's like y over y, divided by h, which is x2 minus x1 simplified. And you will see a couple of different ways of denoting the derivative. And these two are by far the most common. dy dx. So if you see dy dx, what that means is the derivative of y with respect to x. And in this course, we're just going to be working with two different variables, so that's not going to be much of a problem. But this means the derivative of y with respect to x, or the change in y with respect to x. That's slope. Another way of denoting the derivative is f prime of x. These mean that these are the derivatives of the function. So if f of x is your function, say you had this function right here, f of x is x squared, then f prime of x would be a function telling you what the slope of the tangent line is. Or dy dx would be the derivative of the function with respect to x. Just so that we don't always have to write m tan, slope tan. Okay, these mean the same thing, the slope of the tangent line. So what does the derivative actually mean? Well, the derivative represents the slope of the tangent line. Well, we talked about that. So the slope of a tangent line at a point, let's say x naught, represents the change in the y value at that point. So it tells us how fast y is changing with respect to x. So for example, if the slope of the tangent line to a function at x equals 2 is 3, so let's say we were finding the derivative when x is 2, and we were told that the derivative is 3, then that means that when x is 2, the y values are increasing by 3 for every increase of 1 on your x-axis.